let's talk about compound interest. That is, interest compounded at a regular interval, and it might be yearly, it might be monthly, it might be daily or quarterly, something like that. Compound interest is interest that is paid on both the principal. The principal is the amount you invested at the very beginning. We call that the initial investment. And it's the interest that the principal generates over time. So for instance, at the end of the year, if you invested $100, at the end of the year, you would have more than $100. So compound interest is going to generate interest on the new amount as well as the original invested amount, which includes the original invested amount, I should say. So we have to have a bunch of variables, labels here really. So we're going to call P the amount that you invested. R is the rate of interest, and we're always going to write that as a decimal or use that as a decimal when we use it in our problems. And the rate of interest is over a given period of time. When we're talking money, it's usually in years. When interest is compounded or is calculated, that is compounded yearly, the expression for the amount at the end of the first year would be the original amount plus the interest on the original amount, R being the interest rate. Okay? So massaging this a little, let's factor a P out of both parts of that. So P times 1 would be P, and P times R would be PR. So that's one way to write. Another way to write how much money is left at the beginning or at the end of the first year. So P is your principal, 1 year, and the interest rates. Well, in year 1, at the end of year 1, you have this much money. In year 2, you're generating your interest on the amount of money that you generated at the end of year 1. So what I'm going to do is factor this chunk of expression out of both of these parts, so that this times 1 gives me that piece right there, and this times R gives me that piece right there. Notice then, because I can drop those big brackets, multiplied, 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 so it doesn't matter what order you multiply it in, that I have 2 of these 1 plus R expressions. So I'm going to write that as 1 plus R squared times the principal. At the end of year 3, we've got what we started with at the end of year 2, and then we're going to take that amount and generate some more interest, multiply it by our interest rate. Well, this big fat expression is what I can factor out of both of these chunks right here, this chunk and this chunk, so that P times that stuff right there times 1 gives me this piece, and this times that R gives me this piece. Now again, notice that I can drop the brackets. I have 1 plus R 2 times here and 1 time here, so that's 1 plus R raised to the 3rd power times P. Do you see that as many years as we want to do this, will change, the only part that will change will be that exponent right there. So let's pretend it's a whole lot of time, T years. So that means the amount that we have at the end of our investment is going to be equal to the amount we started with multiplied to however much, this expression raised however much time you want to invest this thing. 1 plus R is 1 plus the interest rate, and then raised to the T amount of time, probably in years. Now, if the interest is compounded at intervals, intervals might be quarterly or semi-annually during some period of time, then what we will do is take the interest rate and divide it up by the number of periods in our original time T. So, but when I do that, I'm going to have, I'm going to be doing that for that many years and also that many times each year, which is why that n gets multiplied to the t. It's the number of times we're going to calculate interest. So this is our compound interest formula. The amount at the end equals the amount at the beginning times this expression, 1 plus our interest rate divided by the number of compoundings in a period of time. That is all raised to the number of compoundings times the length of the time involved. That's the compound interest formula. Let's look at an example. Let's say we have $5,000 to invest, and we're going to invest it at 4%, and we're going to compound that investment semi-annually. That is, calculate the interest, add the interest on, and then generate interest on the new, larger amount. So if we're going to do this for 6 years, then we start with our initial amount of $5,000. The interest rate is 4%, which you must translate to be a decimal. Semi-annually means twice yearly, so we're going to divide that interest rate by 2. Then we're going to raise that interest on that amount, or add that interest to that amount, 6 for 6 years times twice a year, so 12 times altogether. And when we do that, we're going to put that expression on our calculator, and it looks like this. 5,000, remember to apply those parentheses, 1 plus 0.04 divided by 2, raised to the, now this is very important. When you put it on your calculator, you want to use a parenthesis around that exponent right there. Let's look and see how much that will be. So here's my calculator. And I have $5,000, 1 plus 0.04 divided by 2, raised to 2 times 6. And that means that after 6 years, my account earning 4% interest will now have $6,341.21.